Hello guys, I have here a combinatorics problem that's a little tricky, not hard to solve, but it has a trick that I want to point out because it's a common mistake the students might make. So while this is not difficult, you can easily have a problem like this in the exam. It has a particular way of getting it wrong, which I'm going to state very clearly. So here's the problem. We have 8 capital letter passwords, so you can see how they look. There's like 8 spots here, and this is A to Z, right? So each spot it's filled with A, B, C, D, up to Z, and we want to count passwords with letter occurring at least 5 times. So we're interested in things that have a lot. One of the letters have to repeat quite a lot, more than half of the time. So if it's eight spots, at least 5 of them have to be, say, an A or a B or C. So there's only 3 spots. We should say that in here. That means 3 spots are not that letter, the one that's repeating. So I'm going to point out how people get wrong this kind of question. So to be clear, this is an incorrect solution, and here's what the student might say. There's 3 things that I have to do here. Suppose I choose that letter to repeat. This letter that repeats, it's this letter here. So there's 26 choices. Say, for example, say I get the letter B to repeat, and then I choose 5 spots. It has to repeat at least 5 times, right? So I choose the spots to put it. Say I get when I make a choice, I have 8 spaces out of 1, 2, 3, 4, 5, 6, 7, 8, and I choose 5 of them. Say I get maybe spaces 2, 3, 5, 6, and 8. Right? I get this particular. So then I put the B in there. I put the B in 2, 3, 5, 6, and 8. Right? So I got now a letter repeating. I have it occurring 5 times. Good. And then I can just fill the other 3 spots with anything. I can literally put anything in there. So that is 26 choices times 26 times 26. Like, for example, say I get a Z, then I get an A, then I get a C. 3 letters. So then I'm going to give a Z here, an A here, and a C here. Right? So those would be, this would be the repeating ones. I'm going to highlight them. And the other ones, the positions 1, 4. This is position 1. This is position 4. This is position 7. These are not that letter that's repeating. So what's wrong with this? It's called double counting. Specifically, in the 3rd step, last step, Jimmy could get another B. So that will be the 6th B. That's okay for validity. There's nothing wrong with having 6 B's. So if you have a spot B, 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 and then some other thing, and then again B, B, and some other thing, and another B, That's okay because it has to be at least 5 times, right? So 6, it's at least 5 times. 6 times is okay. So that's not the problem. The problem is this is double counted. This password, say I get here a and a C. This password is counted 6 times. Because I could have gotten, like I did, I could have gotten, you know, in the first step. So I'm going to give you 2 examples. It's counted 6 times, but I only list 2. I could have in the first step the B's like I had, and then in the last step the first B. That will be this one here, or we could have it in the first step, get, for example, B, 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 and then nothing, and then B, B, and 2 empty spots, right? That's 5 B's. But then in the last step, get the last B. Let me put those in blue so that you guys know what I mean. That's the B that goes in here. Now you can see how these are 2 different ways. I get those 5 B's and then the first B, or I get the other 5 B's and then the last B. So that in Jimmy's counted, these are 2 different ways. By Jimmy, but same plate password. No good. So how do we fix this? This is the problem. This is what's wrong with Jimmy's solution. So what is the correct way to do it? So here's the correct solution. Disjoint cases by the number of occurrences. So let's say I have, the number has to be at least 5. So I have k equal 5, k equal 6, k equal 7, and k equal 8. So I'm not saying I distinct those cases. One is, you know, exactly 5, exactly 6, exactly 7, exactly 8, to not get into this kind of problem. So now in here I repeat Jimmy's strategy for each one of those. So I say, well, choose a letter. So choose the letter. I can do that in you know, 26 ways, of course. I can choose the spots. So that will be, in this case, 8 spots, choose 5, and then choose the rest. That would be, in here I have 3 spots left because it's k equal 5. So that would be 26 to the 3. So that's k equal 5. In here I also have 26 options for the letter. I can choose 6 positions. So this is, of course, times. And I only have 2 spots left, so that's 26 square. Sorry, that's 25. Let me see, this is a mistake here. Let me make it more clear. This is choose the rest. Choose the rest. The rest have to be different than that letter. So this is 25 to the 3, and the same in here. (25) to the second. You can see how even professors can make silly mistakes. So then in here I have 26 options for the letter A. Choose 7 spots where to put it, and then I need another letter again that's different than that one, and then in here I have 26 choices for the letter, but it's repeating 8 spots, so there's no other place, nothing else to choose, because I only have to choose the letter that's repeating. So this will be a sum from k equal 5 to 8 of 26 times A choose k times 25 at the power 8 minus k. That will be the remaining spots. So the answer will be this formula. Again, my point for this problem, to recap, it's not a hard problem, but you can easily, rushed up and get this double counting happening. So as a precaution, every time you produce a solution like this, we call this a generative solution, because there are 3 generation steps here. First choose the letter, then choose the places, then fill the other spots. Ask yourself, am I double counting? Is it possible that I can produce the same exact password in this case with 2 different choices? I can choose, say, different letters or different spots and then fill the other spots, and somehow I get the same password. That's the point of this problem. But usually if you do disjoint cases, make sure they're disjoint, make sure none of those passwords can be in 2 cases, and it cannot, because if a letter repeats 5 times, it cannot also repeat 7 times. All right, so because there's only 8 spots in this password. So that way I know the cases are disjoint, so then if I count each one of them and sum up, I get the correct answer.